Well, welcome. In this video, we're going to be concluding this unit on logarithms. So if you haven't done so already, you do want to make sure you go back and watch some of those previous videos, because this video is going to take a lot of that content that we've talked about and put it all into one. Now, the main emphasis of this lesson is going to be looking at how we can interpret data that would follow a logarithmic curve and be able to create a line or a model for that data. And once we have a model, the point is then that we can use that model to make predictions on some other values. So for example, we're going to be looking at this first example here that deals with a study that was done where what they did is they took and they gave a bunch of words and their meanings and gave them to people to look at and memorize. Well, for some people, they only gave, and the time that they gave people were between 1 and 30 seconds to look at each word and its meaning. So some people were only given 1 second to look at its word and look at the meaning, and some people were given up to 30 seconds for each word and its meaning. And then they gave people time to kind of rest, and then they came back and asked them, well, how much, and they tested them to see how many of those words and meanings they could recall. Now we can see from this table here that when people were only given 1 second to memorize each word and its meaning, we're only able to recall 30% of those words and their definitions. Where people that were given as long as 30 seconds to look at each word and its meaning, were able to recall 85% of those words and their meanings. So you can see also from the graph that you can't see right now because it's hidden behind this wonderful image of me. But you'll be able to see in a second that that data, if you were to graph it out, would be along a logarithmic curve. Well, what we're going to do is we're going to take the data that's in this table and we're going to put it in our calculators. So you want to make sure that you have a TI-inspired calculator for this lesson, because that is what this lesson is going to be revolving around, is knowing how do we use our TI-inspired to be able to graph and be able to use that graph to come up with a model. So let's look at the graph behind me, and then we'll see how we can use the information here to come up with a model. Okay, so here's that graph that I was referring to. So again, you can see that these points, if we were to graph our values for t along the x-axis, and so that would be the length of time that they were given to study each word and its meaning, and the percent on the y-axis. And it's also important to recognize for something that we're going to be looking at later on, is that the percents, they didn't change these to decimals. We're just using these as the percent value. But if we put those on the y-axis, the curve here follows a logarithmic curve. Now what we're going to do is on our calculators, we're going to create a table here for t and p. And I've already done that, so what you want to do is you want to create a column here for t and put those numbers in for t that were on that screen here previously, and I'll go back to that so you can pause it. And then do another column. Give yourself some space here. Give yourself a column here for some space. It's not required, but it'll make things a little easier as far as to look at here in a minute. But then do another column for p and put these numbers in for p. So again, make sure that you're using the numbers that are in this table. So you might want to pause this video so you can see all these numbers and put them into those columns in your calculator. So once you go ahead and do that, when you're ready, once you hit play, when you're ready to move on to the next step. Okay, so going back to your calculator here, what you're going to want to do is we want to take the logarithm of a single variable in this, for this example, because they want us just to take the logarithm of column t. So to distinguish between t and its logarithm, what we're going to do is we're just going to type in the word log. We don't want to put any spaces in here. The calculator will get confused by that. So we're just going to say the log of t here. Now my calculator filled it in because I have this open on a previous screen, but how do I get these numbers? Well, what you're going to do is in this cell here that's gray, first off I want you to look over here on your calculator. If you have a diamond here, you have my operating system, that means. And what that means is you want to use an equal sign to tell the calculator we're going to be putting in an equation. The equal sign is over here next to the 7. So if you look over here next to the 7, you want to type in the equal sign to tell it that we're going to do an equation. And the equation is going to be the logarithm, so do control 10 to the x. Now you might be saying, well, what in the world is going on here? What is this all about? Well, this here is referring to our base. So we don't want to do a base. We're just going to hit the right arrow to say that we want to just put the value here. And we're not going to put any numbers in here. What we're going to do is we're going to say that we're going to take the logarithm of this entire column. Now I could put t referring to the variable, but that's going to confuse my calculator. Because then it's going to ask me a screen is going to come up saying, well, do you want the variable t or do you want to use the column t? I don't want to confuse my calculator, so I'm just going to put this as column A and hit enter. And now you should get these same values. If your calculator says the log of 2 and the log of 5 and the log of 15 here, that's fine. It's just that your calculator is set to be in the exact solution as opposed to the approximate solutions. And by the way, too, going back up here, if your calculator has an equal sign in this spot instead of a diamond, you do not need to put the equal sign in here. In fact, if you do, you probably have a syntax error or some kind of error that'll come up. All you have to do is delete the equal sign and just type in the log of A and you'll be good. Okay, so now we're going to graph out this information. So go to the home button and go to this, looks like it's a histogram or a bar graph that's right next to the spreadsheet. Now your calculator is going to look different from mine. Basically, this is unorganized information. They're just taking this information, just throwing it on the screen. We have to organize it. Now there's two ways you could do that. You could slide your finger around your touchpad to move this arrow down to the bottom down here and click enter. Or what I like to do is I like to go over here and just hit the tab button. Now you're going to have a lot less options than I do here. But we're going to put the log of t on our x-axis. And now for the y-axis, again, I could do the same thing. I could move my cursor over to the left and click enter, but I think it's just easier to hit the tab button. And we're going to use on our y-axis, we're going to use the value for p on our y-axis here, so let's select that one. And now you can see that there's a strong linear relationship, there's a strong correlation between our value for the log of t and our value for p. So that means that we're going to come up with an equation in slope-intercept form for a line of best fit here that would go through these points. So to do that, go to Menu, Analyze, Regression, Show Linear. And we get this equation. So again, the process was to do Menu, Analyze, Regression, and then we want to do the first one there, the Show Linear. So the equation in linear, as a linear equation is y equals 36.2 times x plus 30.1. Let's put that in our notes here. So the equation again that we have is y equals 36.2 times x plus 30.1. But the problem is we want our equation to be in this form. Now remember, x in this equation is really what we did is we took the log of these values. So again, this would be like your x and this would be your y. So the x in our graph was the log of t. So I'm going to replace x with the log of t. And I'm going to use, instead of y, I'm going to use p. So I'm going to say p equals, my value for a is a 36.2 times the log of t plus our constant there is 30.1. So there's an equation in that form. That models the study time data. Now we can use that equation to predict if we want to figure out how long or how much time we would want to give someone to study each word in its definition in order to be able to recall those words and definitions with a 95% accuracy. So remember the percentages, we did not use the decimal form. So I don't want to change this to a decimal. I want to leave it as a percent. So it's going to be our percent is 95 equals 36.2 times the log of t plus 30.1. So I want to solve that equation. That's a logarithmic equation that we're solving. So we want to get the log by itself. So again, this is using some of those concepts that we've talked about in previous videos. So I'm going to subtract 30.1 from both sides. When I do that, I get 64.9 equals 36.2 times the log of t. Again, I want to get the log of t by itself, so I'm going to divide both sides by 36.2. When I do, I get 1.793 equals the log of t. So now I have the t by itself, so now I can get my answer. To get my answer, I'm going to take my base, which is 10, remember we drag that over to the other side, because remember what logarithms are equal to are exponents. And when we do that, we're changing the form it's in to be an exponential form, so the log disappears. So it's going to be t equals 10 to the 1.793 power as your answer. And if I plug that in my calculator, we get about 62.1 seconds. So if I wanted someone to recall each word and its meaning at a 95% accuracy or better, I would want to make sure I give them at least 62 seconds to look at each word and its meaning. Now this video, that example that we're looking at, was one in which we were using the logarithm of just one variable. So we're actually going to break this lesson up into two videos. So in the next video, we're going to be looking at this one, where we're going to use a logarithm of both variables. So with that, why don't we stop this video, and why don't you go on to the next video now to be able to watch how to do this with both variables.